Hey guys, it's your boy Schiff. Today we are talking about factoring. So your homework will be to take notes, come to class tomorrow with any questions you might have, but this kind of fits into our quadratics section. So let's go, shall we? Factoring is the opposite of distributing or foiling, which we've been doing earlier this week, where we take out a GCF. In factoring, what we're doing is we're splitting it apart. So if we were to FOIL this, where we multiply terms times terms, we'd of course get x squared. Then we would do our outside, x times negative 6 is negative 6x. We do our inside terms, which is going to be 4 times x or 4x. And finally, we do our last, or our constants. We're going to multiply them. 4 times negative 6 is going to be negative 24. Then, before we move on, we're going to combine like terms. So for this one, what we get is x squared minus 2x minus 24. So we've turned two sets of brackets into a quadratic equation here. What we're going to be doing today is going to be working backwards. Instead of starting with something that looks like this and moving into three terms, we're going to start with our terms and split them into two brackets. So something in the form of a, where a is the leading coefficient, or the number in front of the x squared, plus bx. B is going to be the number in front of the x with a degree of 1. And then c is our constant. What we're doing is we're going to be splitting it up into these brackets so it looks more like our x plus 4, x minus 6 example up here. Where that's going to come from, where the numbers, the signs, that's what we're going to answer right now. So why do we factor trinomials is the first question you're probably asking. So trinomials have two x-intercepts where they cross the x-axis. So any quadratic will cross the x-axis twice. That is ultimately what we're solving for. More to come. There are different ways. We have the quadratic formula. We can complete the square. But first we're going to learn how to factor. So once we have our factored answer, so as we saw before, we can set each of those brackets equal to 0 and solve for what our x-intercepts are. So down here, let's take a look. X plus 3 times x minus 4 equals 0. We're going to solve for x. So here we're going to get x equals, just subtract the 3 to the other side and we get negative 3. And here, of course, our second x-intercept, if we isolate the x, is we move the 4 over and we get negative 3, and our second x-intercept is going to be 4. So again, that's what we're solving for and why we're doing this. So hopefully you're not that confused yet. But what we're trying to do is find factors of the constant. The constant, remember, is this c, this number back here. Factors, of course, are numbers that multiply to that number. And then, depending on the sign, we're going to find factors which either add or subtract to the inside term, b. So let's first look at this example. What are our factors of 16? What are two numbers that multiply together to 16? Well, we have, of course, 1 times 16. We have 4 times 4. And we have 2 times 8. So those are the only pairs which multiply to 16. So what we're looking for are two numbers which multiply to 16, either option A, B, or C, and which multiply to this inside term 10. So of course, you've probably figured it out. What we're going to do is have x plus 2, x plus 8. Doesn't matter if you put the 2 first or whether you put the 8 first, but this is going to be how we correctly factor this. And then if you want to find the x-intercepts from there, you would set each of these equal to 0 and solve for x. X equals negative 2 or x equals negative 8. So those would be our two x-intercepts solved by factoring. Okay, moving on, let's try a few together. Feel free to pause this right now and try these on your own, or if you're still not really understanding, we can work together. Again, we're looking for factors of 6. Two numbers that multiply to 6, add to 5. So factors of 6, 1 and 6, or 2 and 3. 2 and 3, of course, multiply to 5, so we'll put the 2 here and the 3. We could also, again, put the 3 and the 2. So our x-intercepts would be -2 and -3. Let's try it with this one now. We have x squared plus 7x plus 10. So you're probably thinking, what are the factors of 10? 1 and 10, but that adds to 11. Or 2 and 5, which adds to 7. So x plus 5, x plus 2, or x plus 2, x plus 5, and x equals -2, comma, -5. So there are two separate x-intercepts. And this last one, 24, has a lot of factors. So you're probably starting 24 and 1, that adds to 25. 12 times 2, that adds to 14. 6 times 4 adds to 10. How about 3 times 8? Multiplies to 24, adds to 11. So what we get is x plus 8, x plus 3. And then our x-intercepts, of course, would be x equals -8, x equals -3. Again, if you want to see any of those done again, just rewind the video. You can try it again. All of those are when we have x squared plus bx plus c. So the signs are not always the same. So here, for example, we have x squared minus bx plus c. So the constant is still positive. We still want two numbers that multiply to a positive. However, here they're going to add to a negative. So when that's the case, our signs are going to be x minus, x minus. So it works the exact same way. For example, this one, what multiplies to 12 adds to -8. You're probably thinking 6 and 2. And when we look at it, -6 times -2 is 12. -6x, -2x is -8x. So two negatives multiply to a positive, but add to a negative, so it stays the same. Here, x squared minus 9x plus 14. What numbers multiply to 14, sum to -9? 7 and 2. So here our x-intercepts are actually going to be positive. We're going to say here x equals 7 or x equals 2. So when the signs are -bx, positive c, we're looking for numbers that still combine to add. However, now the last one, most complicated, when the constant is negative, the signs of the brackets must be as follows. So, irregardless of what this inner term is, if the constant is negative, we always have one plus in the brackets and one negative. That's because a positive and a negative always multiply to a negative. So we must solve for b using the difference of two factors. So here we're not looking for numbers that multiply and add, but numbers that subtract. And then what I forgot to include in here is the larger number is always going to go in this first bracket with whatever the sign of b is. I'll explain in a minute. So here, 22, factors of 22 are of course 22 times 1, 11 times 2, and what we want is two numbers that multiply to -22 and subtract, their difference is going to be +9. So 11 times -2 of course equals -22, and then 11x minus 2x is going to give us this inner term of a +9x. So because this is positive, this sign is going to go down here in the first bracket with the larger term. Let's try another one. I know it's a little bit tough. Here we have a -27. and a negative sign here. So since the negative is with the beat, we're going to put negative in the first bracket, and our bigger number is going to go here. So just a little reminder. What multiplies to 27? 27 times 1, 9 times 3. So if we put our 9 here, because it's the larger term, what we get is negative 9x plus 3x equals a negative 6x. And here our x-intercepts, which again is why we're solving for this, are going to be positive 9 or negative 3. Okay, so this is what's to come later in the week. Just a little preview, but try these problems again. If you had a little bit of confusion, go back and re-watch the video. I'm always here for questions if you want to email me or check the blog or write me a response. But tomorrow in class we'll try some applications of this in some group work. But I hope it made sense. I'll see you guys tomorrow. Arrivederci. Ciao.